Welcome to the BDB Semantic Layer workflow. We start by selecting our data connector from the data catalog, here the BFSI dataset. Once inside the connector, we move to the Ontology tab to begin modeling our business concepts. Let's move to the General tab. Here we provide the display name and technical name. Next, we choose the inherent type, either an entity or an event. If required, we can apply a data restriction filter. To define the object, we either select an existing table or use a custom query. Here we are defining the customer business object. While you can map directly to a table, we are using a custom query here. We join the party role, party, and demographics tables to create a unified 360-degree view of the customer, filtering specifically for the customer role type. In the Attributes tab, we refine how this data appears to business users. We take the technical column party_ID and rename it to the business-friendly term, customer ID. We also add synonyms such as cust ID, customer ID, and party ID to ensure consistent understanding across different data sources, and we also categorize this as internal data, ensuring that governance and data sensitivity rules are applied right at the semantic level. Now we add intelligence. We define derived measures like total relationship balance, which is a pre-calculated summation of all customer accounts. We also create derived dimensions, such as tenure band. Using a SQL case statement, we automatically segment customers into new, established, or veteran based on their start date. This logic now lives in the object, not in scattered reports. Next, we move to the Relationships tab. Here we link the customer entity to other business entities. In this case, we've created a left join with the collateral table. This ensures that future queries can automatically fetch asset details for a customer, without the user needing to write any complex join logic. Next, we define functions. We've created a table-valued function called customer collaterals. This accepts a party ID and returns a structured list of that customer's assets. We can preview the output right here to ensure the logic is calculating correctly before saving. Next, we define a function for customer holding. It accepts a party ID as input and returns calculated customer holding details, which we can preview here before saving. To make this object actionable, we define an action, KYC verified. This is a database update operation that changes the status to verified and timestamps the record. Crucially, we enforce an action policy. Only users with the manager or finance manager role can execute this workflow, securing your business process. Once saved, we can visualize our work in the knowledge graph. We see how our new customer object connects to party, demographics, and transactions, creating a fully traversable semantic map for the enterprise. And that's how we convert raw data into a smart, business-friendly semantic layer. Thank you for watching.